Hello, I'm Benjamin Williams. Welcome back. Today we're going to be doing another Boson NetSim lab. We're still within the security section within Boson, still learning a lot. Today we're going to be working with NTP security or network time protocol security. So this is the first lab for network time protocol, and the next lab will be the same. So we'll be probably just be doing something else with NTP. So the objective in this lab, it says you will configure network time protocol on a master NTP server and on 2 NTP client devices. You will additionally configure each of the client devices to authenticate NTP packets from the master NTP server. Also, you will use access control lists, ACLs, and NTP access groups to restrict NTP synchronization from the master NTP server and to NTP clients. So that makes sense. So this is our topology that we have. We have our 8 switches connected down to our PCs, of course. Going up, we have our fast Ethernet connections up to our distribution layer, or our layer 3 switches right here. And then from our distribution layer, we have a little bit of redundancy from our distribution going up into router 1, or you could say the core of the network. So if one of these connections goes down from the D switches, it can just go the other path. So let's say from D switch 2, if this link goes down, D switch 2 can just forward the traffic over to D switch 1 and then up to router 1. So it's always good to have a little bit of redundancy in your network just in case something goes down. But that's what I noticed as I was looking at this topology. We have our command list right here, which lists all of our commands. We already read through all of those earlier, and we've read through our description as well. So let's go ahead and go down. We have our IP address information right here for reference. We're going to be doing our usual. We're going to keep our topology up here in the top left. We're going to be doing all of our configuration reading top right, and then we're going to be doing our CLI commands down here at the bottom. So let's go ahead and get into it. It says configure NTP for task 1. In this task, you will configure NTP on router 1, D switch 1, and D switch 2. Router 1 should provide NTP synchronization services to both D switch 1 and D switch 2. So it looks like router 1 is going to be our master NTP device, and everything else is going to sync up from router 1. So it's going to be our master. So it should have our lowest stratum number. That's the way that NTP works. So on router 1, it says set the clock to 6:09 coordinated universal time on August 26, 2014. So let's go enable, and let's do set clock. Okay, hold on, set, and maybe I need to go into global config, and let's do set clock. Okay, so no, maybe not. Maybe I need to do clock. Okay, so let's go exit, because I thought we were supposed to do this in privilege exec mode. So let's do clock set. Yeah, I was doing it the wrong way. All right, so we want to set it for 6:09 quarter. So I think that's like military time, and I have to look it up to do the conversion. So I'm just going to have it show me the solution that it wants. So it's 18:09:00. So I'm gonna do 18:09:00, and we want to do the date first. So that it told us to do the 26th. Next we'll probably, it says the month, so August, and the year, and wants us to do 2014. All right. Just want to see what the actual time would be for universal, coordinated universal time, or UTC. So it says, on router 1, verify the current time. From what source is the time and date? So let's do a show clock, and no, a show clock detail, so we can see where it was. Okay, so you can see right here that we have it set for 6:09 universal time for August 26, 2014, and it says our time source is user configuration, or because we just manually configured it. So that's right. It says on router 1, enable NTP by configuring router 1 as a master NTP server with a stratum of 10. So let's do conf t NTP master master. And we want to create a stratum level of 10. Enter. All right. So it says, what is the importance of the stratum value in NTP? So, the stratum value basically tells you the NTP's authoritative level. So if it starts out with a lower stratum level, that means that its time source is coming from like the naval base has a atomic clock, and its stratum level is 0. So most of like the Googles of the world and people that send out the time that most people use for their devices, they get those from actual atomic clocks. So Google servers, NTP servers will probably have a stratum of 1 because they will get their time source from a stratum 0 or an atomic clock like the naval base has. So that's the importance of NTP. Let's see what it says right here. So the authority of a particular time server is indicated by a stratum. So yeah, that makes sense. It says on router 1, verify the current time. From what source is the time and date set now? So let's do a do show clock detail. And we can see our time source is now NTP because we made it a master NTP server right there. So perfect. So it says on D switch 1 and D switch 2 display the current time. Is time on either D switch 1 or D switch 2 synchronized with any time source? So let's go to D switch 1 and D switch 2. First, let's start on D switch 1. Let's do an enable. Let's do a show clock detail. So you can see that it has no time source, and it's set for Monday, March 1st, 1993. So it doesn't have a time source. And let's do the same thing on D switch 2. Let's do a show clock detail. And it has no time source as well. And it's also set to have a UTC time of Monday, March 1st, 1993. So that's not correct. So on D switch 1, configure NTP to synchronize the time with router 1 through router 1's fast Ethernet 00 interface. So let's go back to D switch 1. Let's go conf T. Let's do NTP. And we want to do context sensitive. So we want to set the server to be, let's go back to, let's reference our IP address table. So it wants us to do the router R1's fast Ethernet 00, I believe it said. Yep, fast Ethernet 00. So fast Ethernet 00's IP address is 192.168.51.49. All right, let me make sure it doesn't want a key before I hit enter. So, yep, we're good here. And on D switch 2, it says configure NTP to synchronize the time with router 1 through router 1's fast Ethernet 01 interface. Let's do conf T. Let's do NTP server. And let's reference our IP address table one more time. So the IP address for the fast Ethernet 01 connection is 192.168.51.53. Oops. 53. All right. I think that's good. So it says on both D switch 1 and D switch 2 display the current time. Is the time on each device synchronized with the NTP source? So we probably need to give it a little bit of time because NTP does take a bit of time to synchronize its clock. But let's see if we have it. Do show clock detail. Okay, so at least on D switch 1, we're synchronized up now with router 1, and we can see that it has the right date that we configured on router 1, and it says its time source is NTP. That's what we want to see. And it should have this D switch 1 should have a stratum level of 11 because it's getting its time from a stratum 10 device. So let's go over here. Let's do a do show NTP. Oh yeah, do show clock detail. And its time source is NTP as well, and it has the same time source as we configured on router 1. So that's perfect. All right. It says on D switch 1, examine the status of NTP. What stratum is being reported and why? So let's do D switch 1. Let's do a do show NTP status. And let's look here. It has a stratum level of 11. Like I said, its clock is synchronized, and its reference is 192.168.51.49, which is that connection up to router 1 where it's getting its time. So that's perfect. On D switch 1, examine the NTP association. From where is D switch 1 time being synchronized? What is the stratum of the NTP source? So let's do it. Do show NTP association. And we can see that it is getting its time from 192.168.51.49, which is router 1. Its reference clock is the actual reference clock on router 1. So that's this address right here, which is 127.127.1.1. And router 1 has a stratum of 10. So that is all good right there. That's what we want to see. So it says configure NTP source security. Cisco devices can use NTP authentication to verify the source of NTP packets. In this task, you will configure NTP authentication so router 1, D switch 1, and D switch 2 so that packets from router 1 are verified by D switch 1 and D switch 2 before D switch 1 and D switch 2 use those packets to synchronize their clocks. So we're using a little bit of security here to prevent our source devices from synchronizing to a rogue NTP server, which is always good. You want to have security throughout your network to keep attacks down and things of that nature. So it says on router 1, display NTP association. What authoritative source is being used to synchronize the time? So it should be using this local clock because it is our NTP server. So let's do a do show NTP association. And yes, it's using this local clock right here, which is this address. You can see its reference clock is local, which we want. And it says what authoritative source is being used to synchronize the time. Well, that's this local clock. That's the authoritative source. So it says on D switch 1, display NTP status. Is D switch 1 receiving its time from router 1? So let's go to D switch 1. Let's do a do show NTP status. And is it receiving its? Yes, it is receiving its time from router 1, as we can see right here. So that's answered. On router 1, enable NTP authentication. So let's go back to router 1 and let's do an NTP authenticate. All right. And it says on router 1, configure an NTP authentication key that uses an ID of 1, a password, and a password of Boson. How does NTP use authentication keys? So before it synchronizes its clock, it makes sure that all the devices have the same authentication key. If they don't, then they won't synchronize. I believe that's the way it works, but I'm going to read that to make sure that that's the correct explanation. So let's first do the configuration. So it says we need to do NTP. Let's do a, it says use authentication keys. So let's do authentication key. And we want to do authentication key of 1, and we're going to do MD5, and then we're going to do a password of Boson. Perfect. MD5 is a hashing algorithm. I think AES is another hashing algorithm. But let's see why it says NTP authentication keys is a mechanism by which an NTP client verifies the authenticity of an NTP source. It is important to note that Cisco devices use only message digest MD5 for NTP authentication key. However, MD5 keyword is required when this command is issued. So it verifies the authenticity of an NTP source. So that's what we want. We want our sources to match up with router 1's source or router 1's key, so it does synchronize its clock. So perfect. On D-Switch 1, display NTP associations. Is D-Switch 1 still synchronized with router 1? Why or why not? So let's go to D-Switch 1 and let's do a do show NTP association. And it looks like we're still synchronized up to router 1, even though we configured an authentication key on router 1. So let's see. D-Switch 1 is still able to synchronize with router 1, even though router 1 has been configured with NTP authentication. NTP authentication only enables a client to verify the identity of the source of NTP packets. It does not prevent unauthenticated clients from synchronizing with NTP servers or other NTP peers. So that makes sense. It's saying basically it just verifies the source of the NTP packets, making sure it's coming from the right source, but it doesn't prevent anybody from actually synchronizing. So, okay, that makes a little bit more sense now. On D-Switch 1, configure NTP to use authentication. So let's go to D-Switch 1. Let's do NTP authenticate. Perfect. All right, now it says on D-Switch 1, configure NTP authentication key that uses an ID of 1 and the password of Boson. Let's do NTP authentication key, and we want to do an ID of 1 and MD5 of Boson for our password. Perfect. On D-Switch 1, configure NTP authentication to trust packets from only NTP devices that authenticate by using authentication key number 1. What will D-Switch 1 do with NTP packets that claim to be from router 1 but do not use the trusted key? So I believe here, since we're doing the trusted key, it will not synchronize from devices that claim to be router 1 that does not have that trusted key. It has to have that trusted key in order for it to sync its clock. So that's what I'm going to say for that. So let's do trusted. Okay. Let me do, maybe I need to do NTP trusted key, yes, of 1. All right, that's perfect. All right, now let me read why. You can configure multiple NTP authentication keys on the device. NTP trusted key 1 command configures the NTP client to accept authentication key number 1 as a valid key for authentication with an NTP source. When configured with a trusted key, NTP clients will drop NTP source packets from a given NTP server if those packets do not contain the key. So instead of synchronizing, it's just going to drop those packets. So it won't synchronize, and it's going to drop all of those packets that don't have the trusted key. So that makes sense. On D-Switch 1, reconfigure NTP to synchronize over router 1's fast Ethernet 00 interface, and you should modify the configuration so that it uses NTP authentication key number 1. So we need to reconfigure D-Switch 1. So let's do no. Okay, let's do a. Do I need to do a no NTP here, or can I just go straight into the config? Okay, yeah, I just go straight into the configuration. So NTP server. And we want to do fast Ethernet 00 on router 1. So let's go back up. Make sure we get the right address. So its address is 192.168.51.49. And we want to do a key of 1 here. And let's go down just to make sure that's what it wanted us to do. Yes. Oh, right here. Yes. So authentication key of 1. So let's go ahead and hit enter here. And on D-Switch 1, display the NTP status. Is D-Switch 1 still synchronizing its time from router 1? It should be. Let's do a do show NTP status. and its stratum is still 11. Its reference is still router 1, so everything is still synced up as it should be. So it says on D switch 1, display the NTP status. Here we just did that. Okay. And it's still synchronized with R1. So let's move on to question number 11. On D switch 2, configure NTP to use authentication. So let's go to D switch 2. Let's do NTP authenticate. Perfect. Alrighty. And on D switch 2, configure an NTP authentication key that uses an ID of 1 and a password of Boson with a $sign. Oh, it says ensure that the password is not identical. So it wants us to use this, and I guess it wants us to use this password to show that since the passwords are different, D switch 2 is going to drop the packets from D switch from router 1 and not synchronize its clock. I'm going to go ahead and skip down to D switch 2 because I don't want to put the wrong configuration in and then have to reconfigure it again. So let's go ahead and do it the right way first. Well, let's just go to question number 13, and then down here it has us reconfigure it looks like. So first, let's do on D switch 2, configure NTP to trust only NTP devices that authenticate by using the authentication key of 1. So let's do a NTP, and we need to do a trusted key of number 1. Perfect. All right. On D switch 2, reconfigure NTP to synchronize over router 1's Fat Ethernet 01 interface. So we're right here, number 14. Let's do that. Let's do a NTP server, and let's go up and get router 1's Fast Ethernet 01's IP address. So that should be 192.168.51.53. And we want to do a key of 1. That's what we want. Yes, that's what we want. Enter. Alrighty, and it says display the NTP association. Well, it's not going to be associated, and the reason why is because it wanted us to put in this bad password. So right here, it shouldn't be. If I would have put in that bad password, it would not be synchronized. But since I didn't, I'm just going to wait. First, I'm going to configure it with the right stuff, and then I'm going to do a do show NTP association, and it should be associated with router 1. So let's do that now. Let's do a NTP authentication key of number 1 and a MD5 password of Boson. All right. So now let's do a do show NTP association, and everything is looking correct. We're synced up with router 1's Fast Ethernet 01 address. It has a stratum of 10. Everything looks good here. Let's make sure everything is still good over here on D switch 1. And it looks like it is. The clock is synchronized. Let me do the same command over here. Do show NTP. Let's do NTP status. And this clock is synchronized. So yeah, everything is good. So let's go to task number 3. It says configure NTP client security. Although NTP authentication verifies the source of NTP packets, it does not prevent NTP clients from synchronizing with unauthenticated sources. In this test, you will configure ACLs and NTP access groups to ensure that router 1 can synchronize time to only D switch 1 and D switch 2. You will also configure ACLs and NTP access groups on D switch 1 and D switch 2 to ensure that those devices can only receive their time from only router 1. So on D switch 2, display detailed information about NTP associations. Is NTP on D switch 2 synchronizing with router 1? So yes, we can see right here that it is synchronized with router 1. On D switch 1, display NTP association. Is NTP on D switch 1 synchronizing with router 1? Yes, we can see that right here it is. So On router 1, create an ACL with an ID of 10 and configure it to match permitted traffic from D switch 1's fast Ethernet 06 interface. So let's go to router 1. Let's go. Let's do an access list to make an ACL ID of 10. Let's permit, and we want to permit D switch 1's fast Ethernet 06 interface. So let's go D switch 1's fast Ethernet 06. So it should be permit. Let's do a host of 192.168.51.50. And let me make sure that's the right config that Boson wants before I submit that. So it doesn't want me to put the host. You can specify the host, but it doesn't want me to. So that's fine. It'll be really the same thing that I just did. It just wants a little bit different. And it'll grade me wrong if I don't do the exact config that it wants. So it's O.O.O.O for the wildcard mask. All right. On router 1, configure NTP to synchronize this time only to D switch 1 and to not permit NTP control queries using ACL 10. NTP should not be able to synchronize router 1's time from D switch 1. So let's do let's do NTP. Let's do, what do I need to do here? Let me read that one more time. It says, on router 1, configure NTP to synchronize its time only to D switch 1 and to not permit only its time to D switch 1 and to not permit NTP query controls using ACL number 10. So let's do access group of we want to, it says it wants it to what? This time to only service NTP to synchronize this time only to D switch 1 and to not permit NTP control queries. So I think it wants us to do serve only because it doesn't want us to do any. Yeah, it wants us to do yeah, and then 10. Okay, let me make sure that's what it wanted. Serve only. Yeah, serve only. Okay, got you. Because it doesn't want any, it says it doesn't want any query messages. So serve only just gives it server access. So on D switch 1 display NTP association, is D switch 1 synchronizing this time with router 1? So let's do an do show NTP association. And it looks like we're still good. We're still synchronized up with router 1, which is perfect. On D switch 2, display detailed information about NTP association. So since we didn't create the ACL for D switch 2, I'm not sure that it's going to be still associated. Do show NTP association. And it looks like it's still synced up. Let's do it a few more times to see if it still stays synced up. So maybe I have to wait a little bit because NTP does take some time. But it says based on the output, you can determine that NTP client on D switch 1 is synchronized. Okay, so it's supposed to stay synchronized up. Okay, just wanted to make sure. Oh, hold on, that was supposed to be right here. Yeah, so it's not supposed to be. So let's give it a little bit more time and see what it does. Yep, so we can see right here that it says unsynced, and it has that little hash right here. When we're synced, we get the tilde that's up here. But now we see the difference with the hash. Oh, well, not the tilde. We get the star when it's synced up. But we get the hash when it's not. And we can see our stratum changed to 16. And anything over 15 is not believable. So, yeah. D switch 2 is not synced up. So let's go to router 1. It says modify the ACL number 10 to permit traffic from D switch 1's fast Ethernet 06 interface. So let's go over back to router 1 And let's do an access list number 10. And let's do a permit. We want to permit a DSwitch2's Fast Ethernet 06 interface. Let's go back up to go to DSwitch2's Fast Ethernet 06 interface, which is 192.168.51.54 and 0.0.0.0, because we want all of those bits to match up. So we have a slash 32 address configured. All right. Now on DSwitch2, permit traffic. Okay, we did that. On DSwitch2 display NTP association, is DSwitch2 synchronizing this time with router 1? So let's go over to DSwitch2. So we're back to the star, which means we are synced up to our master clock, and our stratum is back to 10. So perfect. On DSwitch1, configure an ACL with an ID of 10 in the access group that permits DSwitch1 from synchronizing this time with any device other than router 1. So let's go over to DSwitch1. Let's make an access control list over here, ACL of 10. And let's permit. And we want to permit on DSwitch1, it should be the Fast Ethernet 00. Oh, I can just use, okay. I can just use the output that I have right here. So we want to permit 192.168.51.49 0.0.0.0. Perfect. And it wants us to do the same thing on DSwitch2. So first let's do an NTP access group. And let's do it wants us to peer with number 10. Okay, perfect. And let's go back to DSwitch and let's do the same config over here, access list 10. And we want to sync up to 192.168.51.53 on DSwitch2. Okay, maybe I did something wrong. Access list number 10. We want to permit. That's what we forgot to do. And let's do a 192.168.51.53. Oops. Typo. O.O.O.O. All right, and let's do an NTP access group of 10. Access group of peer of 10. All right, I think we're good. Now on DSwitch1 and DSwitch2, display NTP associations. And let's see if it's still associated with R1, which we should be. Let's do a do show NTP source. And everything looks good here. Is what we want to see is synced up. Let's do a do show NTP source over here. And we can see we're synced up, which is perfect. So everything is looking good. On router 1, DSwitch1 and DSwitch2 display detailed clock information at the time consistent across all devices. So let's do a do show clock detail. Before we hit enter, I'm just going to get all of these ready on each device. Do show clock detail. And let's do a do show clock detail. So let's hit enter, enter, and enter. So August 26, 2014 is 1839.13 right there, 1839.12. in 1839.11. So everything looks to be matched up. All of the time sources is NTP. So let's go ahead and grade. Hopefully we got everything correct, and we did. So thank you guys for watching this video on NTP security. I'll see you in the next one.